Hello everyone. Today, first we will discuss about basics of DSA. So the first topic is algorithm. So algorithm is nothing but finite ordered sequence of ordered sequence of instructions that, when executed, solves a given problem and produces output. So to remember this definition, you have to uh, you have to memorize these two words, finite and ordered sequence. These are both important keywords of algorithm. Okay. So next we'll take example, sum of two numbers. So here I will tell you how we write algorithm. So we'll write like that first step one. So step one, here we will start. After that, step two, we have to take two variables a, b. At third step, we'll sum a plus b. At fourth step, we will print sum. At step 5, we have to stop the algorithm. So in exam, you have to write this step 1, step 2 because it carries a marks. So you have to write it in this way. Okay. So the next topic we will talk about is algorithm design. So there are four types of algorithm design. One is brute force. So in brute force, it will try all possible tries all possible solutions. It is simple to implement, simple, but it is inefficient, not very useful, and it takes very much time. So example for brute force is linear search. Okay, so now we will talk about our next algorithmic design, divide and conquer. In this method, we have to divide problem into sub problems, small problems. Divide problem into sub problems and after that we have to solve step by step. For example, merge sort and binary search. We'll discuss in depth in our next videos. So the next type of algorithmic design is greedy method. So in this, choose the best option at each step. Option at each step. For example, Kruskal algorithm. Now the next type of algorithmic design is dynamic programming. In dynamic programming, it stores results of subprograms. So the example of dynamic programming is Fibonacci using DP. So our next topic is complexity of algorithm. Of algorithm. Algorithm complexity measures the performance of algorithm. In simple words, we can say that it measures the performance of algorithm. There are two types of complexity algorithm. First is time complexity. Time complexity tells us time taken to execute an algorithm. Time taken to execute an algorithm. And on the other hand, space complexity. Space Space complexity tells us memory required by an algorithm. How much space required for a algorithm? Memory required by an algorithm. So the next topic of this module is asymptotic notation. It describes how algorithm performance goes as input size increase. It describes how algorithm performance grows as input size increases. Input size increase. There are four types of asymptotic notations. First is big O notation. Big O notation. We can denote it as O. It gives the upper bound of time complexity. Bond of time complexity. It guarantees maximum time taken. It guarantees maximum time taken. It comes under worst case. For example, bubble sort. Bubble sort takes O n square of time. Now, the next type of asymptotic notation is big omega notation. Big omega notation gives lower bound. We will denote it as omega, a symbol of omega. Okay. In it, minimum time is required. Minimum time required. It gives best case. Example, linear search. Now our next type of notation is with theta notation. We can denote it as O and inner omega. It represents tight bond. It gives both upper and lower bound. Upper and lower bound. It gives average case. It takes average time to complete the algorithm. That's why it gives average case. Example, we can take it as binary search. We can take binary search as O log n. Now, our next topic is data structure. Data structure is our fifth topic. Data structure is nothing but method of organizing and storing data so that operations like insertion, deletion, searching, and updating can be done efficiently. Why? Now the next question is why we need data structure. So the first thing is efficient data access. Optimized memory uses faster processing. Now we will discuss about the tree of data structure. So these data structure, this is, now there are two types of data structure. First is primitive, second is non-primitive. So in primitive, basic data type provided by programming languages like int, float, etc., which are provided by programming languages. On the other hand, non-primitive data structure is nothing but data derived from primitive data structure only. So there are two types of non-primitive data structure: linear, non-linear. In linear data structure, there are four types: array, stack, queue, linked list. In non-linear data structure, there are two types: tree, graph. So in DSA, we will discuss only about non-primitive data structure only. Okay. So this is all for today. We will meet in next video. Goodbye. Thank you.